Hello all students, welcome back to AgriEdic. Last series we have seen the mock test on soil pedology and taxonomy. This mock test series we are going to see about the soil physics portion, and myself Abishek, I am currently pursuing the PhD in soil science from ICAR New Delhi. So let's go into the mock test series. First question, they asked about the arrange the following forms of soil consistency into increasing soil wetness. So here they asked about the ascending order of soil wetness parameters. So first they will see which parameter is dry. So it should be, the parameter should be from the dry to more wetness. So first we will see the hard one. So next is friable. So somewhat more moisture, that is soft. Then more than that soft, some higher moisture is plastic. This plastic is the one of the important parameter. Like in many exams they will ask like what is the plasticity index or what is the plasticity. Plastic is nothing but whenever the soil you can deform into any shape, you can mold into any shape without any deformation. So that is the plasticity limit or plastic index at which this moisture content, the soil will behave like a clay ball. So you can mold into any shape without any deformation. So after this plastic limit, the more moisture content is sticky. This sticky is the one, it is having the highest wetness. So we'll match this with the options. First E, then friable B. So option D is the correct option. Then moving to next question. Here they are given two statements. First they given the assertion, the particle density value, they told like it is always higher than the bulk density value, and the reason they have what they have given is in particle density they considered the volume of whole soil. First let's see what is particle density, what is bulk density. In this particle density they mainly focused on soil solids. Like if you take density mass by volume, here they have considered volume of soil solids only, and but in bulk density if you take, here they have considered volume of soil solids plus pore spaces. So here they have, in particle density they didn't taken the whole volume of soil, they have excluded the pore space. So what the reason they have given, they have volume of whole soil is considered, so they have not considered the whole soil, they have considered only the soil solids and they excluded the pore spaces. So this statement is, this reason is wrong. And but the assertion, you can see this particle density value, it should be always higher than the bulk density. So the option is, assertion is true but the reason is false. Okay, we are going to the next question. Here they are given some of the statements about the tensiometer. Tensiometer is one of the important instrument in measuring the field condition soil moisture. So that is one of the important question they can ask is, in field condition, that is in situ soil moisture estimation can be done by which instrument, that is tensiometer. And here they given some of the statements, one by one we will see. First statement, it is saying like it measures the soil water potential. Yeah, it's true, because the tensiometer having a tube filled with water, then in the down it is having a porous cup. If we insert this porous cup into the soil, when the soil is dry condition, so that time this water will go to the soil based on the concentration gradient difference between the vacuum instrument and the soil. So here the vacuum will be created when the water is transferred to the soil. So based on this vacuum, the soil moisture tension will differ. So that soil moisture tension will measure using this tensiometer, that is tensiometer. And it is simple also in operation and is useful for scheduling irrigation also. Based on this value we can go for the irrigation scheduling also. And third one, they are given like it measuring the soil water flux. Soil water flux is nothing but it is one of the soil water rate. So here they measure only the potential. Rate is nothing to do with this tensiometer. So infiltrometer, like that, another instruments will be there for measuring the soil water flux. So another this option won't come. C also not come. Only A, B came. And going to the D option, they are given like, although it's this working capability is limited below 1 bar, but this range can be increased by increasing the permeability of the porous cup. So what will happen if the permeability of this porous cup will be increased? For example, if you are increasing the permeability of this porous cup by giving more space or pores more, so automatically more air will go into this vacuum. So this will make the instrument to work inaccurate. So when the air becomes more means, so it will easily become the vacuum whenever you are inserting the tensiometer into the soil. So optimum that permeability of the porous cup is needed to maintain this instrument to work correctly. So this fourth option also not correct. So only the A and B is correct. Then moving to the fourth question, here also they given like two statements. First we will see the pores having diameters more than 0.06 mm are called macropores. Here we have to know that one information. 0.06 mm is more than 0.06 mm is macropores, and less than 0.06 mm is micropores. Macropores is important for the soil air circulation, and in the macropores most of the soil air circulation will happen, and in the micropores most of the soil water circulation will happen. So this first statement is correct because more than 0.06 mm only macropores. Okay, then we will see the second statement. Macropores having great importance in water retention in soil. Actually, macropores is important for soil aeration. Since the size is bigger, air can easily flow towards this macropores rather than the micropores. But micropores is very much important for the soil water circulation, because the soil water will be holded by this micropores effectively than the macropores. So this statement 2 is wrong. So statement 1 is true, but the statement 2 is false. The option C is the correct. Then we'll going for the next question. Which of the following is not associated with particle size analysis? Students will see what is particle size analysis. Particle size analysis is nothing but it is a soil textural analysis. As we know, soil texture is the relative proportion of sand, silt and clay. So while we are determining the how much percentage of sand, silt, clay in a soil, we will go for the international pipette method. That is also one of the important question. International pipette method. International pipette method given by Pipette Robinson in 1966. So in this method, it is a standardized method and it is having the highest accuracy in determining the particle size analysis. So here they asked the which option or which of the following is not associated with particle size analysis. So first option we will see, that is dispersion, because obviously we have to disperse the soil particles before going for this analysis in the international pipette method analysis. So this is not associated. It is associated with particle analysis. Because first step we will do, that is dispersion of the soil particles. Then fractionalization, this also will do, because based on the size you will fractionize into different categories like sand, silt and clay. Okay, then this also associated with particle size analysis. Then flocculation, here we will see because if you want to analyze sand, silt and clay means you have to separate it, but here they are telling like flocculation. Flocculation is nothing but it is the coagulation or combining the separated particles. So here in particle size analysis, but we have to do the deflocculation, but here they kept like flocculation. So this is not associated with particle size analysis. So third option will be the correct one. And sedimentation also, it will be associated with the particle size analysis. In the final step of this international pipette method, you will go for the sedimentation based on the Stokes law. That is also one of the important question. Sedimentation is based on the Stokes law. Stokes law. Stokes law is nothing but the velocity of the falling or sedimenting particle is inversely proportional to the viscosity of the medium. Then next question, a layer of ice formed on the surface of lakes in cold regions, because here they told like the cold in the cold regions the lakes will be there, so in that the layer of ice will be formed. It is mainly because of what the reason they asked. So first reason, they are telling like ice is less dense than liquid water. Yeah, obviously ice because water it will be highest dense compared with ice. Because of that density difference only ice is floating on the liquid water. So this option will be the correct one. And second, there is no exchange of heat, but it will happen in the ice also. The exchange will be happening like convection or conduction or radiation may happen, so we can't tell that. And cold winds, it is very meager reason, and ice is obviously it is not denser, so it is not there. So ice is less dense than the liquid water. Because of this only the ice is floating on the water. So moving to the next question, terracing is an effective method of soil conservation in which of these areas? So terracing, first terracing is nothing but if you take a slope like this, to reduce, if the rainfall is coming, to reduce the runoff loss, we will set up a mechanical measure of bench terrace or zinc terrace, that is terraces. This is terrace. So obviously this terracing will happen wherever the slopes will be steeper or higher in the range. So where it will be higher, the slopes will be higher in the hilly region obviously. So option A will be the correct option. Then moving to the next question, the angle formed between the oxygen and hydrogen in the water molecule is, this is one of the factual question. The water molecule, if you take the water molecule H2O, the angle between the oxygen and hydrogen, that is formed in 105 degrees Celsius, sorry, degree 105 degree, and when we going for some range, means the range is 103 degree to 106 degree. If you want to tell accurate, that is 105 degrees angle. So coming to the next question, that is agronomical measure for soil conservation is, in this word only you can derive the answer. Agronomical means it's like crop management. So in this 4 option, which one is coming like crop management? Obviously this one, strip cropping. So strip cropping is nothing but the, if we plant the crops in a way, in such a way that if you plant erosion permitting crops plus erosion resisting crops along with that in a field, both planting of erosion resisting and erosion permitting crops, that is strip cropping. So going to the next question, evapotranspiration is directly measured by, they have given some of the instruments. First we will see the pan evaporation. Pan evaporation is one of the method that they will measure only the evaporation. Okay. Then next option they given like Penman-Montlith equation. It is one of the empirical method to estimate evapotranspiration, because in this empirical method they will derive using the equation, so it is not a direct measure. And regarding the third option, hygrometer. Hygrometer is related to measuring relative humidity, so it also not coming under evapotranspiration. And the remaining one is lysimeter. Lysimeter is the precise and direct measurement of evapotranspiration. Lysimeter, if you take in a field, if you take one, they will take one container. In that container, they will keep like plants as well as soil. So based on the weight of this soil and plant and the difference between this weight difference, they will conclude the evapotranspiration. Okay. Then going to next question. Given here they have given that two statements. Assertion they have given like mulches conserve the soil moisture, and the reason they are giving is mulches cut off the solar radiation falling on the soil surface and reduces the evaporation. So as we know, mulches is a considered in the no tillage operations, and it will conserve the soil moisture by the insulating effect on the soil or field. So it reduces the, like for example, if you take any residues like mulch, soil on the soil, the solar radiation will go, but due to this mulches, due to this insulating effect of the mulches, soil will remain, soil temperature will remain constant. So it will reduces the soil temperature, and because of this soil temperature reduction, and it will conserve also the soil moisture by reducing the evaporation. So the reason also it will be correct, because it conserve the soil moisture through reducing the evaporation. So the first option will be the correct one. Both assertion and reasoning are true, and reason is the correct explanation of assertion. Then we are moving to the next question. Direct method of determination of soil moisture. Here we will see they given like 4 methods. Out of these 4 methods, you have to find the odd one out, because all these 3, this gypsum block, tensiometer, pressure plate apparatus, is all are indirect methods. For example, indirect method is nothing but used on the some soil properties they will measure. Soil properties, they will measure soil moisture. For example, gypsum block method, they use the soil electrical resistance. Based on the electrical resistance of the soil, they will measure the soil moisture. And in tensiometer method, first they will measure the soil moisture potential, then based on that they will determine the soil moisture. And pressure plate apparatus also, it follows the same indirect method. So only thing is the direct method is gravimetric method. Here they will take the initial weight and final weight. Based on the difference between the initial weight of the soil moisture and final weight of the soil moisture, they will consider the soil moisture. So option 1 will be the correct. Then moving to the next question, what are stored in, they have given like here 4 statements. Out of this, you have to choose the correct statements in these options. First, they told like water stored in the root zone is called as green water. Then second one, the concept of soil water potential is introduced by Buckingham. Then the statement is capillary fringe zone above groundwater table is mostly unsaturated. Then soil water retention in soil is a function of adsorption and capillarity. First, let us check out which are all the options are correct. Okay. First, the root zone water, that is green water. Yes, absolutely correct. Whatever the water present in the root zone, that is called green water. For example, if you take blue water, that is present in water bodies like lakes, rivers, that is blue water. Green water is water stored in the root zone, that is green water. Yeah, that then the statement A is correct. Then the concept of soil water potential is introduced by Buckingham. This is also one factual question. This is also correct. Then third option is capillary fringe zone above the groundwater table is mostly unsaturated. Here you have to find this the mostly unsaturated like that they given, but it is above the groundwater table. So we have to logically think above the groundwater table, almost it will be nearly saturated zone. So if you take soil zones, there will be 3 zones. One is root zone, another one is vadose zone, another one is capillary fringe zone. Below that, water table will be there. So if you take this water table nearby that zone, this is fully saturated with water. So automatically this zone will be nearly saturated with water or saturated with water. So capillary fringe zone is nearly saturated or mostly saturated, but they in the option they given like it's mostly unsaturated, so this option will be wrong. This statement is wrong. And fourth statement they given like water retention in soil is a function of adsorption and capillarity. Absolutely, whenever the adsorption between the soil particles and water and capillary rise, like due to the adhesion and cohesion of the particles, the soil water will move forward, that is capillarity. So the soil retention, the soil water retention, it is by the adsorption and capillarity, so this option will also be the correct. So only the B will be wrong, so we will see the A and C, D. Okay, this B option will be the correct one. Then we are going to next one, which is Reynolds number. Here you can see Reynolds number is mainly used to determine whether the flow is whether the fluid flow is laminar or turbulent. First let us see what is laminar, what is turbulent. For example, if you take the soil in the pore space, like water will move in a continuous manner based on this pore space, this is laminar flow. For example, if you take big pipelines like pipe canals, the flow will be the irregular manner, so that is turbulent flow. So based on this Reynolds number we can determine which the soil flow is laminar or turbulent. So Reynolds number here they given like different option they get given, but out of this they are asking which is the definition of this Reynolds number. So exact definition is the ratio of inertial force of flow to the frictional force, because we told like laminar flow, this is the inertial flow. Inertial flow means whatever the force you are going. For example, if you are going in a car, the suddenly it stops means you will not fix into that car, so that is inertial force. Some jerk you will be getting that that is the inertial force. And frictional force is, for example, if water particles are moving in line by line, sometimes this water layer collides with this water layer, so this friction, internal friction will happen, and this internal friction will reduce the flow. So the ratio of inertial force flow to the frictional forces flow, that is called Reynolds number. And this Reynolds number ranges from 1 to 10 for laminar flow, and for the turbulent flow it will exceed more than 2000. Then moving to the next question, which of the following is not an erosion permitting crop? So you see the options. First you have to find out the odd one out, like here maize, wheat, palm nut, legumes, all these three are coming under cereals or monocots, and this comes under dicots. So whenever the dicots are planted in this any hilly area or steep regions, you will having the maximum crop coverage area, which will reduce the erosion, and it will add more biomass into the soil. By that you will get the good soil binding capacity also. So legumes will be the correct option. This is not erosion permitting crop, this is erosion resisting crop, because of this soil binding capacity of legumes and this crop soil coverage area of the legumes. Then who formulated the soil universal soil loss equation? The universal soil loss equation is given by, this is one of the factual question, Wishmeyer and Smith, and that equation will be coming like function of erosion is equal to RKLSCP. This equation, it's important, you can learn from this. And going to this next question, they given like 4 statements. Out of this you have to choose the correct statements. So first statement we'll see, time domain reflectometry, it's based on the principle of dielectric constant. Time domain reflectometry is one of the indirect method of measuring the soil moisture content. It is also soil moisture measurement, but it is based on the dielectric constant of the water. So soil water having around approximately 80, the value of dielectric constant of soil water is highest, more than soil or anything. So water having the highest dielectric constant, so more than the soil. So this to measure the soil water, the time domain reflectometry, here they are using the dielectric constant. So this statement is correct. Then option B, soil psychrometer can measure the total soil water potential. Total soil water potential means it's nothing but osmotic potential plus gravitational potential plus pressure potential. Yeah, here psychrometer is the only instrument they can use the both all the soil water potential they can estimate. So this statement also correct. But if you take a tensiometer and all, they will consider only the metric potential like or osmotic potential. So here they are considering total soil water potential. And third statement, in neutron moisture meter, boron trifluoride is used as a detector of slow neutron. Yes, here also the statement is correct. Boron trifluoride is used as a detector for detecting the thermalized neutrons from the soil, the detector from the neutron source. So here this works like the fast moving neutrons collide with hydrogen ion from water. So this neutron will collide with water, and this fast moving neutrons after collision it will become slow. So this slowed neutrons will detected by boron trifluoride in the neutron moisture meter. So boron trifluoride is used in detector of neutron moisture meter. That statement also correct. And we're going to the fourth statement. Thallium activated sodium iodide crystal is the source of gamma ray in gamma ray attenuation method. Gamma ray attenuation method is also one of the soil moisture estimation method. But in this gamma ray attenuation method, they have used source as a cesium 137, not thallium activated sodium iodide. Thallium activated sodium iodide is a detector, same like boron trifluoride. It is one of the detector, not the source. Source is radioisotope of cesium 137. So this is also an important question. In gamma ray attenuation method, which is the source means that radiation source is cesium 137. So this fourth statement is wrong. So except this fourth statement, all are correct. So A, B, C statement is correct. So option A is the correct one. A, B, and C. So next question, when the liquid wets the soil, the contact angle is acute, which they have asked acute or obtuse, or contact angle does not have any relevance on the wetting surface. Then they have told like both acute and obtuse. Okay, first we'll see one example. This is the acute angle. Acute angle is nothing but less than 90 degree. That is acute angle. And more than 90 degree, if you take, that is obtuse angle. Whenever the water falling on the soil, it will be, as we know, whenever the water falling from the rainfall or through irrigation, the water try to spread like a film, thin film. So it will be like this. This angle will form. It will spread like this. So automatically this acute angle will form. Acute angle is that is less than 90 degree. So acute angle will form. But for example, some of the waxy coated soil or any hydrophobic soil, if you take, the water won't spread like that. So in that situation, the obtuse angle will form like this. This is for your information. Like obtuse angle will form only on the hydrophobic soils. So here normal soil, when the water reaches the soil, it will spread like a acute angle. So acute angle is the right option. Then going to next question, diameter of a very fine sand according to the USDA classification of soil texture. We'll see the options 0.05 to 0.002 mm and 0. Because here you can see this option you can easily remove, because more than 0.2 it doesn't come under fine sand, so this you can remove easily. And 0.012 to 0.0005 mm, this is the correct option for this fine very fine sand according to USDA classification. So this is the one of the important factual data. This you have to learn based on the different sizes. So how USDA classification will differ, how the Indian Society of International Society of Soil Science classification will differ. So maximum the JRF questions or SRF questions will come from this international IEEE classification only. So this USDA you can see for additional information. And going to the next question, the ratio of eroded sediment carried out of a drainage basin to the total amount of sediment moved within the basin by erosion process is called. They given a one statement, and it seems to be like a definition of a one particular statement. Okay, first let us break the question. First they told like the eroded sediment carried out of a drainage basin. So let's take one basin. One basin is there. When the water is going inside, and here some vegetation is there, like some crop is there, and after that it crosses all the vegetation, and the erosion, some erosions will happen here, and it will crosses, and it through the outlet it is coming out, that is sediment outlet. So how much the sediments coming out of this basin, how much the sediments it's still retained in the basin. Here they have asked like this kind of ratio, like how much sediment ratio sediments out coming out of this basin, and how much it retained in the basin. So it is the sediment delivery ratio, how much delivered outlet, like how much the sediments delivered outlet, because this first option won't come, because sediment deposition means it retained only they are considering, but here they asked how much it coming out of the basin. So sediment delivery ratio is the exact answer for this question. And a transportation index it won't come, because it is not a ratio, and factor it won't also come, because this is also not a ratio. Then going to next question. If the laboratory temperature decreases from 25 degree to 22 degree Celsius, the time taking for reading of soil water suspension in textural analysis for soil separates will, they told like increase or decrease or remain the same, or temperature having no relevance to that. So we'll see whenever the, here we have to apply the Stokes law, because when you are talking about soil texture you have to come with the Stokes law. Stokes law is telling about the velocity of the falling particle is directly proportional to the density of the particle and inversely proportional to the viscosity of the particle. So whenever the temperature decreases from any like temperature decrease will happen, so automatically viscosity will increase. So whenever the temperature increases, the viscosity will decrease, because whenever the temperature, here it is showing like the temperature is decreasing, so when decreasing the viscosity will increase. Option A is the correct. Then we are moving for next question. If porosity of the soil is 25%, then what is the value of void ratio? Void ratio having one formula, E is equal to n by 1 minus n. N is already having the porosity, that is 0.25 or 25%, we are writing like 0.25, then 1 minus 0.25. So if you derive this, it will come like 0.33. So 0.33 is the void ratio. Okay. Then next question we'll see. They given one statement and a reason. Water retention in lower potential range depends primarily on the soil texture, soil structure, and the reason they are giving for that is at lower potential the water retention depends primarily on the adsorption, which is a function of surface properties of the soil. First, let us see the assertion. At water retention at lower potential. Lower potential means we can consider negative potential, like for example minus 20 bars. It shows the soil is very dry. So in that water retention in that lowest potential, in the driest condition, it depends primarily on soil texture, like that here they are saying. But when you take the field condition, whenever the soil will become dry, the major factor it decides the soil water retention is surface area, specific surface area. The surface area decreases means the space to hold the water will increase, but here they told like primarily on soil structure. So soil structure won't work, soil specific surface area only will focus more on this. So this statement is wrong. But the reason they given like at lower potential at a driest condition water retention depends primarily on adsorption. Yeah, definitely adsorption of soil that water on the specific surface or area of the soil, which depends on the surface properties. Because of this soil porosity or soil specific surface area, these surface properties will play a major role at the lowest potential or driest water condition. So assertion is wrong because it doesn't at the driest condition water retention doesn't depends on the primarily on soil structure, but it depends on specific surface area and porosity. So assertion is wrong, but the reason is correct. So A is false and the reason is true. So option D will be the correct one. Then coming to the next question, which radioisotope is used for soil moisture study? Let us see one by one. Cobalt 60, it is mainly used for irradiation purposes, in medical field or some other fields. And next option, cesium 137, as we discussed in gamma ray attenuation meter in soil moisture estimation, this cesium 137 acts as a electron radio source for this gamma ray attenuation meter. So this is cesium 137 is useful in measuring the soil moisture studies, and iodine 137, this is used in medical field for thyroid and all. And carbon 14, it's mainly used for carbon dating, not for soil moisture. So cesium 137 is mainly used for determining the soil moisture condition. So B will be the correct for soil moisture studies. So coming to the next question, here they are telling like field A and field B. For example, one field A, one is there, and field B is there. In one field A, they considered no tillage practices, and in the field B, they are considering conventional practices. So they asked, if the temperature measurements is taken in the early morning, what is the outcome? So we already discussed mulching has the important role in no tillage practices rather than this conventional practices, because mulching acts as a very good insulating material. Insulating material is nothing but which is protecting the soil from extreme temperature conditions. So in this while you're using the mulching material in the no tillage practices, the temperature of the this field A will be almost reduced only because of this mulches compared with conventional tillage field. So the temperature, the option B will be the correct one. Temperature of field A is less than the temperature of field B. Then going to the next question, here they given two statements. First one, higher structural coefficient value indicates the higher structural strength. Yes, of course, structural coefficient is higher means automatically the structural strength of the soil will become higher. Yeah, it is absolutely correct. Then second statement, a lower CMWD value indicates higher structural strength. CMWD is nothing but coefficient of mean weight diameter. CMWD is coefficient of mean weight diameter. This CMWD value will derive using the wet sieving technique given by Yoder. So in that we will analyze the aggregate stability. For example, in that we will take series of sieves which is having different pore size. We will create the artificial rainfall condition or water condition, and we will keep the aggregates here, and whenever the rainfall strikes these aggregates, if it is the weak aggregates, it will break towards and it will come down. So if it is very strong aggregates, the lesser it will break and lesser and it will retain more on the upper portion only. So if the aggregates are weaker, the more sedimentation will happen. So this lower this CMD this will gives the lower CMD value. So this will give the higher CMD value. So if the lower CMD value means this particles will be lesser here if it is lower CMD value, CMWD. So it is the inverse relation here. If lower CMD value means higher structural strength, if higher CMD value means lower structural strength, but here they given like lower CMWD value indicates the higher structural strength. This inverse relation ratio is correct. So the statement 1 and statement 2 both are correct. So both statements are true. Then moving to the next question, the zone which is characterized by the steep hydraulic gradient and beyond there is no noticeable water penetration is found. If we take the soil water movement as a field condition, for example, it will start with the infiltration. For example, if you take soil, it start with infiltration. After it will go percolation. Percolation is mainly by the gravity. This is also one of the important question. Percolation is mainly due to the gravity, and infiltration, it is the first step of the soil water movement in the soil. It will happen. So after the water entry, this water will go like up to certain level. So after that it won't go beyond that. So we'll see in the next picture, you will understand. So this is the wetting front. So after this area, it won't go beyond that. So until that it will come. So wetting front is the boundary between the dry and wet soil. So it is the steep. It is up until it will come the water, but after that there is no noticeable water will be coming. That is the wetting front. So here they given wetting front. Wetting front is the correct option. And here you might be confused with, they have given zone, so you have to choose zone, not like that. Sometimes the question will differ, so you have to analyze all the options. Transmission is different, and transition is not a technical term in this soil water. And wetting zone is there, but wetting front is the keyword. So after this front there is no noticeable water penetration is found. Here they given this condition, so based on this condition, this front is the exact answer for this. Then moving to the next question, they have given regarding the oxygen diffusion rate in the soil. So out of this we have to select the correct options. First, ODR means the rate at which the oxygen is diffusing into the soil. So it is expressed in microgram per centimeter per minute. So this unit also correct. So ODR is nothing but at which rate the oxygen is diffusing through the soil. At if the soil is heavy textured soil, the ODR will be lower because of this compactness. It won't and the heavy textured nature of that soil, the oxygen diffusion rate will be lower. But in the same case, if you take the coarse texture soil, the oxygen diffusion rate will be higher. And then A is the correct one. Then ODR measurement is unaffected by soil moisture or air filled pore space in the soil. This is actually wrong, because ODR measurement is basically determined by the how much water and how much air present in the soil. If the water is more, the ODR rate will become lower, because in a waterlogged condition, if you take, the ODR will be lower because the water won't allow the air to diffuse into the soil. So this is the wrong. And regarding the third statement, electrode poisoning occurs due to the calcium carbonate and or micaceous clay deposits on the platinum electrodes. So there might be a chances of this contamination in the electrode. So calcium carbonate, for example, if you take the calcareous soil, so it will easily attack this electrodes, and micaceous clay also will easily interact with this electrode. So this correct. And regarding the ODR, this ODR of 1.5 microgram per centimeter per minute generally indicates the sufficient oxygen level for the plant root growth. So this is the value they given, and the threshold value for the root growth to stop, that is 0.2 microgram per centimeter per minute. So below this value, automatically root growth will stop. So there is very less oxygen will diffuse after this. So lowest ODR value is this, but here they given like 1.5, that is well above the ODR value. So this also will correct. It indicates sufficient oxygen level for plant growth. Yes, it's correct. Then option B only the wrong. So A, C, D will be the correct option. Then coming to the next question, which of the statements is true with respect to the tensiometry? As we discussed already this regarding tensiometer, we can easily derive this answer by it will focus only on the matrix section, because it won't focus on osmotic potential, it won't focus on gravimetric potential or any other potential, rather than only the matrix section. So tensiometer measures only the matrix section, and they given like A option, it measures the soil moisture content. It will measure, but it indirectly measures the soil moisture content. So it directly measures only the soil moisture content. So A also wrong. Then C they given like they measures total potential, because total it won't, because it measures only the matrix section. And D they given like it measures both matrix and pneumatic. No, pneumatic also it won't measure. Pneumatic it's measured by the soil psychrometers, not tensiometer. Okay, then B only the correct option. So option B is the correct option. Then with regarding to next question, they ask like while designing any mechanical erosion control measure, which of the following you will consider? The first option they given like any crop, because as we had discussed in the earlier slides, erosion permitting crops and erosion resisting crops both are there. So in the condition of erosion prone areas, we will go for the erosion resisting crops like legumes to reduce the erosion. So type of the crop also an important point. And then coming to next, amount of rainfall received in the area. Yeah, for example, if some of the rainfall is like below the average, like less than 600 mm rainfall, and here they will go for the mechanical erosion control measures like graded bending. So rainfall also important factor. Then slope of the area. Slope of the area, it is the major factor which will decide which mechanical erosion control measure should take place. For example, if steeper slopes or higher slopes are there, means people will go for the bench terracing or zinc terracing. So this slope also very important factor. And D is area of the watershed, because based on the area of the watershed, the mechanical control measure extent will go. So this also correct option. So all these options are correct. So option D will be the correct option. So all these factors are considered before designing any mechanical control erosion control measures. Then going to next question, which crop is effectively used as an indicator plant for determining the permanent wilting point in the soil in laboratory, as it depletes the available soil moisture evenly and completely. Here first you see all the crops. Out of these crops, sunflower is the only crop which is having high evapotranspiration rate, which will sensitive to moisture stress. So for example, if wheat is showing the wilting symptom in 1 month, means this sunflower will show the symptoms 10 days prior to the wheat. So automatically sunflower is the very sensitive crop to permanent wilting point. So sunflower, due to this highest evapotranspiration rate, it becomes the sensitive crop to permanent wilting point. So option C is the correct option for this question. Then with regard to next question, which of the following irrigation scheduling method does not rely on soil moisture measurements to determine when to irrigate? Regarding the irrigation scheduling methods, we'll normally use pan evaporimeter, then soil moisture sensor also we'll use to determine the time to irrigate, and soil psychrometer also will use, tensiometer also will use, and soil evaporimeter we won't use, because soil evaporimeter is only determining for evaporation, not for soil moisture. Soil psychrometer also will use. So this only focuses on evaporation. All this focuses on moisture estimation. So based on the moisture, we'll try to estimate that scheduling of irrigation. So pan evaporimeter is the correct option. So with regard to next question, which is the term used to describe the process of using vegetation to enhance the water drainage and stabilize the soil in agricultural landscape? In this question, we can easily identify they are using the vegetation. So for enhancing the drainage and stabilization of the slope, they are using which of the following methods uses the vegetation? As the option itself we can see, the vegetative filler strips. This is the effective vegetation method they are using for the stabilizing of the soil slopes. This terracing it is a mechanical measure, so it won't come directly under vegetative. And riparian buffers, it is not directly coming under the slope stabilization, but this vegetative filler strips directly coming under the slope stabilization and drainage, and subsurface drainage is not relevant to this question. So vegetative filler strips is the correct option. And with regard to next question, which sector uses the most amount of water in India? Actually, being an agrarian economy and being an blessed with monsoon seasons, this agriculture sector is consuming almost 80 to 90% of the total water used by the out of the all sectors. Agriculture is the major sector using the water, 80 to 90%. Here this fact sheet is useful for your JRF or SRF preparations, because of this major factual data, like how much fresh water is available, how much groundwater is available. And here from this statistics, last year they have asked one question, how much groundwater is available for utilization, like 433 billion cubic meter, and how much surface water is available for surface water usage of irrigation, that is 690 billion cubic meter. So this fact sheet is useful for your preparation, so try to learn it. Then going to the next question, Darcy's law is valid in a porous flow media if the Reynolds number is, they given 4 condition. If the Reynolds number increases more than 1, I have told it will become turbulent flow. Turbulent flow, it won't applicable for Darcy's law, not Darcy's law. So option 1 is wrong. Then option 2, yeah, exactly. Option 1, less than 1, it's coming under laminar flow. So it is applicable for Darcy's law. Darcy's law only applicable for the laminar flow. This is the important point they will ask in the any exams questions. And if you take the more than 2000 or less than 2000, this coming only in pipe flows. It won't come under soil condition, not soil condition. So this option also won't come. So option B is the correct one. Less than 1, Darcy's law is valid. Then next question, pumping of excess soil water by deep rooted plants using their bioenergy is called. Here we have to analyze the question very carefully, because here they are pumping the excess water. For example, if you take in a waterlogged condition, how you will remediate or pumping the excess water using these strategies. Here they told like deep rooted plants, so automatically this will not come. Hydro means only water, it is not using this plant, so hydro is not come. Then subsurface drainage also not using deep rooted plants, so it won't come. Out of these two options we have to analyze which one is apt to this. So phyto drainage, yes, it will use the plants, as well as bio drainage, it is also using the plants, but only thing here they asked using their bioenergy. So this is the keyword. In this bio drainage is the right option. Phyto drainage, it is also using the remediation of this excess water, but in the bio drainage it is using the deep rooted crops like eucalyptus for pumping the excess soil water by evapotranspiration, like more evapotranspiration will be there, so automatically it will pump out the excess water from the soil. So bio drainage is the apt answer for this, because of this highest evapotranspiration energy, bioenergy. This bio drainage will pump out all the excess water by the deep rooted plants like eucalyptus. Phyto drainage it will do, but it is mainly focused on the soil pollution remediation, like that. Then coming to the next question, ploughing across the slope in hilly region is called as. For example, if you take one slope, it is a mountain or hill. This is the contour points connecting this mountain. This is they are telling like ploughing across the slope. Across the slope means like this. So along the contour lines across the slopes, this is contour lines or contour points. So along the contour points or across the slope, so is called as contour ploughing. Across the slope means, this is the keyword, contour means across the slope, so contour ploughing is the right option. Then coming to next question, it is the match they given like theory which is proposed and who proposed the theory. And first we will see the out of this option we have to see the which one is easiest, we already know, so better to take that option and we'll match that option and we'll exclude the elimination, we'll exclude the other options by eliminating method. So we will say the time. So first one we'll see the soil textural analysis. It is mainly based on the Stokes law. So soil textural analysis, it's Stokes law. And the wavelength of emitted radiation and temperature is depends on Wien's law. Wien's law, for example, the emission is directly proportional to that maximum emission or maximum wavelength is indirectly proportional to the temperature. So wavelength of emitted radiation is inversely proportional to the temperature, that is Wien's law. Then diffusion of gases, that is Fick's law. Then saturated flow in soil, that is Darcy's law. So we'll see first soil textural analysis, it is for the Stokes law. So B, you see which one is that is option D. So you can easily eliminate the other options, so better to save the time. So next question is saturated hydraulic conductivity in situ is measured by which they given like 4 instruments. So from that you have to find out which is measuring the saturated hydraulic conductivity. First we'll eliminate which are the option is irrelevant. So piezometer it measures the groundwater table water pressure, so it won't come. So infiltrometer it is measuring the infiltration rate, so it is also won't come. Neutron probe it is measuring the soil moisture in situ condition, so it is also won't come. But the except one is the permeameter. Permeameter is nothing but like it will measure the ability of the permeability of the soil. So permeability is nothing but the hydraulic conductivity only. So permeameter is the instrument used for measuring the saturated hydraulic conductivity. Then coming to the next question, it is a factual question. The original design of tensiometer was proposed by William Gardner. Then regarding the next question, the PF range of soft or friable consistency of the soil. PF range is nothing but it is the logarithm of the soil moisture tension. pH is logarithm of hydrogen inactivity, but PF is logarithm of log of soil moisture tension. So we'll see the range of this PF. While you see the more the PF range, increasing range of PF, it will show the reduction in water content. If you take the option they have given, 2.8 to 2.5 is the soft or friable consistency. It is the optimum range. From this PF values we can derive 2.8 to 4.5. This is less available to wilting, friable or soft. So as we told, whenever the PF range increases, the water level also will reduce. So whenever the PF range decreases, water level will increase. So here the less than 0.5 saturated, which means water is already having in a good portion. So in a like completely saturated condition, PF range will be 0. Saturated condition, PF range will be 0. Okay. Going to the next question. The steady state soil infiltration rate is, they given like 4 options: soil surface controlled, then soil profile controlled, then water supply controlled, then groundwater controlled. First we'll see the soil surface control. Steady state means the water flow, it's in a steady position, so it will go in a constant manner. So it is not about the surface control, because surface there won't be any constant, because if you any vegetative barriers or any ridges will be there, or any furrows will be there, that steady state won't be occurring in the infiltration rate. So it won't come. Soil surface control, it is not surfacely controlled. And next option is soil profile control, because whenever the infiltration rate starts, it will go into the soil profile and it will move in a as per the pore continuity of the soil. So it is soil profile controlled in a steady manner, in a based on the concentration gradient between the pores, it will move in a steady manner. That is soil profile control. Then profile control is the correct option. And water supply also, it is an external factor, so we can't tell for this steady state flow. And groundwater control also, it is below the water table, so we can't tell for this steady state flow. Steady state flow is completely dependent on the soil profile control. Then coming to the next, PF curve is same as we have seen, like PF is nothing but logarithm of soil moisture tension. So we have to find out where the soil moisture tension option is there, or metric potential is there. Potential is nothing but that tension only, metric tension or potential relation. Then option D will be the correct. Okay, students, we have completed this mock test series on soil physics. We have discussed many questions. If you liked the discussions and if you have any doubts, please comment below this in this video. And if you want these slides with discussed material, please go through the description. The Google form link is there. Just you fill the Google form with your details, and the slides which we have already discussed, it will be shared with you for your broader discussion. So thank you, and all the best for your upcoming exams, and do well in your exams. Like, share and subscribe our YouTube channel. Thank you.